Hi, these are the answers for CCEA Fact File 5.4 Chromatography for their A2 chemistry range. So, the first question is, a mixture of amino acids may be separated using paper chromatography. Explain the term RF value as applied to paper chromatography. Well, the RF value, or the retardation factor, is simply measured or simply worked out by taking the distance moved by the spot divided by the distance moved by the solvent. So it's always going to be less than or equal to 1. Explain what a low RF value indicates about a particular amino acid. Well, if it's low RF value, that means that it's more soluble in the stationary phase than in the solvent or the mobile phase. Succinic acid can be analysed by converting it to the diethyl ester and submitting the ester to GLC analysis. Why is it better to use the ester rather than the acid in the GLC analysis? So you could say here either the ester is more volatile or that it will pass through the column faster. So more volatile means it turns into a gas much more easily. Okay. Then explain the results expected if the sample of the ester was 90% pure. Well, in that case, if it was 90% pure, you would expect one peak with 90% of the area. And then other peaks, which are the impure bits, would have 10% of the area. Now it says on the fact file that that's worth 1 mark, but in the mark scheme it actually says it's worth 2. Number 3, which one of the following is not true for gas liquid chromatography of a mixture? Well, the answer is actually A, but I'll read the rest anyway. So A is the mobile phase is a liquid and the stationary phase is a gas, which we know it's the other way around. B is the molecules in the mixture have characteristic retention time, which is true. More volatile components of a mixture have a low retention time. We know that's true. And D, the percentage composition of the mixture can be determined. Well, yes, it can. So you just need to make sure you read that question properly. If it's a negative, make sure you're going for the one which is, not true. Okay, and then number 4, the chromatogram below was produced by two-way paper chromatography of a mixture of amino acids. And what we have here is different spots, W, X, Y, and Z, and then 2 solvent fronts. So solvent front 1 is here, and solvent front 2 is here. Now, in this, you just need to get your ruler out and have a bit of a go at working out the RF values. So when you do that, and now I'm not going to go through them all because it would take me forever, but when you actually do measure them, so the RF value, if you remember, is the distance travelled by the spot by the distance travelled by the solvent, or the distance to the solvent front. So for if we look at W, just looking at solvent front 2, that is the distance travelled by the solvent, and that is just the distance there travelled by spot W. And when you work that out, you would get 0.26. If you did it this way, so that's solvent front 1, and that is distance 1, so you're just working those out. Now, you don't actually need to do both, because if you look at these, all of the solvent 1 RF values are different. So if you just work out one of those and then check it with the solvent 2, that should be enough. So you're at most going to have to do 1, 2, 3, 4, 5 little calculations. But if you're lucky, you start with W and cuts down your time an awful lot. Okay, so the answer there was W. Thank you for watching.